So, yung buoyant force natin is still related to fluid mechanics or pressure pa rin. Sa related pa rin naman siya sa pressure. Ano ba ang buoyant force? So, buoyant force is the upward force exerted by a fluid onto an immersed object. So, halimbawa, okay, meron tayong isang object. Okay, so meron tayong tubig, and then may lagay kang object doon sa tubig. Ayan. Okay? So yung tubig or yung fluid ay mag-e-exert siya ng force dito sa ating object. At ang force na yon ay isang upward force na tinatawag nating buoyant force. Okay? So lahat ng fluids, okay, pag in-immerse mo ang isang object sa kanila, ang fluid na yon may exert siya ng force na tinatawag na buoyant force. Kaya class, na ang direction lagi is upward. Kung halimbawa nasa land ka, 'di ba? Syempre, okay ka lang naman. And then pag nagpunta ka sa tubig, nag-swimming ka, 'di ba may feeling ka na mas magaan ka. Okay? Mas magaan ka. Kasi yung meron kasing force na na-exert yung liquid or yung tubig sa'yo. At yung force na yon ay tinatawag nating buoyant force. So may kumakounter kasi sa weight mo pag nandun ka na sa tubig. Okay? So merong tumutulong sa'yo para para i-counter yung weight mo. So depende bang weight is ang direction niya is always downward. Diba meron tayong weight dyan. Okay? Kaya pag mineasure mo yung weight ng isang object sa tubig, na nasa tubig siya, tapos winame mo yung object. So, halimbawa, winame mo yung isang object. So, meron tayong object. Okay? Tapos, kinuha mo, mineasure mo yung weight niya. Okay? So, sabihin natin weight 1 niya. Tapos, nilagay mo siya sa tubig. Ayan. Tapos, winame mo ulit siya. Okay? So, meron kang weight. So, winame mo ulit siya. So, yung weight ng 1 is magiging siyang greater than yung weight no, or yung pag winame mo siya, winay lang ha. Pag tinry mong i-measure yung let's say yung tension na lang. So, yung tension 1 at saka yung tension 2. Ayan. So, yung tension 1, mas mataas na siya sa tension 2. Okay? Pag tinimbang mo yung dalawa, hindi na sila magkapareho. Pag yung object ay nakasubmerge siya sa tubig. Kasi meron nang tumutulong dun sa object para merong tumutulong na force na nagka-counter doon sa weight ng object. Okay? At ang force na yon ay tinatawag na buoyant force, which is directed upward. Ayan. Okay? Nababasa niyo ba? Yan. So, kung titingnan niyo yung figure dyan, so meron tayong, halimbawa yung object na yon. Okay, so kung kukunin yung FBD ng object, so meron tayong buoyant force which is directed upward, and then yung weight ng object which is directed downward. Yeah. Okay, so there must be an upward force to balance the downward gravitational force, which is the weight, and then the magnitude of the upward buoyant force must be equal in magnitude of the downward force. If the object will not be moving, so halimbawa, yung object natin ay, yan, okay, so mag-stay lang siya dyan, kaya siya static. So, ibig sabihin, pag nag-stay lang siya sa ganitong posisyon at hindi siya gumagalaw, yung weight ng object ay equal siya sa buoyant force. Okay? So, yung weight ng object equal siya sa buoyant force. Okay, the buoyant force is the resultant force due to all the forces applied by the fluids surrounding the parcel. Okay, so anong ibig sabihin ng statement na yon? Ang buoyant force daw, so let's say we have an object. Ayan, so nag-submerge ang ganyan. So nandito siya, di ba? Sa ilalim ng tubig. So yung buoyant force daw ay equal siya doon sa summation of forces. So halimbawa kasi nandito yung object natin nakasubmerge siya sa tubig. So yung liquid natin, yung fluid natin is mag-exert siya ng force sa lahat ng surface ng object. So meron sa taas, okay, meron din sa baba, Meron sa side. Okay, meron din dito sa side. O, meron din sa side dito. At meron din sa side dito. Ayan. Okay? Pag pinag-add lahat natin ng force na yan, equal siya sa buoyant force. Okay, class, remember that statement. Okay? Buoyant force is equal to the force or the sum of all the forces acting on the object. So, on all edges, on all surfaces. Okay? So, pag pinag-add natin ng force na yan, yun yung equal siya sa buoyant force. So, that's by definition of buoyant force. Okay? Ayan. Okay, so next one. Kung i-consider natin na perfect square yung object natin, na ganito, so that means, as perfect cube pala. So that means yung force dito tsaka force dito, maka-cancel out. Tama ba? So yung force dito tsaka force dito, maka-cancel out. So yung force din dito tsaka force din doon, maka-cancel out. Ano lang ang matitira? Kasi equal din naman yan. So ang makatitira ay, okay, so that means that's equal to force at the bottom minus the force on top. Okay, kaya pwede natin din i-describe na yung buoyant force equal lang siya sa force sa bottom minus force sa top. Okay? So, yan ang definition ng buoyant force. So, isa lang yan sa definition ng buoyant force. Ngayon, pag pinag-uusapan ng buoyant force, ang laging kasama niyan ay yung pangalan ni Archimedes. So, si Archimedes yan. So, ang nakadiscover ng nature ng buoyant force. So, inventor siya, mathematician, physicist, and an engineer. Okay, so since siya ang naka-invento na naka-discover ng nature ng buoyant force, so meron siyang ginawang principle. So based sa Archimedes principle, ang sabi dyan, the magnitude of the buoyant force always, class, always equals the weight of the fluid displaced by the object. Okay. So sabi sa Archimedes principle, yung buoyant force daw equal siya dun sa weight of the liquid or fluid displaced. So equal daw siya dun sa weight nung na-displace na liquid. Nagets na ba? Yung weight ng na-displace na liquid. So halimbawa, okay? Okay. So, alimbawa, meron akong container. Okay? So, meron akong container. Ito yung liquid. Okay? Ngayon, meron akong ilalagay na object. So, kumari bilog. Ayan, ilalagay ko yung object. So, pag nilagay ko yung object, siyempre, matter, occupy space. So, pag pumunta siya dito, so yung tubig natin mag-displace. So, halimbawa, nandito yung object natin. Ayan. So, yung liquid na nandito sa position ng object, siyempre, pupunta siya sa ibang lugar. Kaya, magdi-displace yung liquid natin. So, tataas yung height or level ng liquid natin. So, ang gagawin nyo lang ay kunin niyo yung weight ng liquid na to. Okay. Pag nakuha nyo yung weight ng liquid na yan, equal siya sa buoyant force. Ayan. So, equal siya sa buoyant force. So, yan ang sinasabi na Archimedes principle. So, yung buoyant force daw, equal siya dun sa weight of the displaced liquid. Weight of the displaced liquid. Okay? Weight of the displaced liquid. Okay. Okay, class. Merong iba-ibang klase ng, di ba sa chemistry, ginawa niyo na yon. Di ba para pag kukuha ka ng volume, pagkuha ng volume, Pag regular shape lang yan, pag regular solids yan, meron tayong formula. Okay, so naalala nyo pa ba yung mga formula natin? So let's say for cube, ang volume ng cube ay S cube. Yan, S cube. Pag rectangular parallelepiped, pag rectangular na ganyan, ayan. So volume is length times width times height. Pag sphere, paano yung sphere? Ang volume ng sphere? 4/3 pi r cube. Tama ba ako? Okay, and then pag cylinder, okay, volume is pi r squared times height. Ayan. So, may mag-alala, puro ganyan lang yung mga solids na gagamitin natin. Ayan. So, kasi kailangan natin yung volume. So, volume pala. Volume ng sphere. So, kailangan natin yung mga volume. Ayan, pag nag-solve kasi tayo at alam lang natin ng density, so para makuha natin yung weight nung na-displace na liquid. Okay? So, halimbawa naman, meron din tayo ng object dito, tapos hindi siya fully submerged. Ayan. Kumari, ganyan lang siya. Okay. Ano ang magnitude ng buoyant force? So, yung buoyant force natin is equal lang siya doon sa weight nung submerged part. Ayan. Okay, so weight nung liquid or ang volume nung liquid displaced ay equal siya doon sa volume ng submerged part. Ayan. Volume nung submerged part. Volume ng submerged part. Okay? May question? Okay, kailangan tandaan yung definition ng buoyant force na yan. So una, ang buoyant force is equal sa summation of forces acting on the object when it is submerged underwater. And then yung second definition is equal siya sa weight of the displaced liquid. So kailangan natin yung volume na nakasubmerge kasi kukunin natin yung volume na yon para makuha natin yung weight ng displaced liquid. Okay. Now, let me go back to this figure. Ayan. Okay. So, hindi ko lang kung kakasya yung... Okay, dilipat ko na lang. Okay. So, let's define ulit yung formula para sa buoyant force based on Archimedes principle. Okay. So, babalik ako dun sa drawing ko. Na kumwari ay nakasubmerge siya. Okay? So, meron akong force at the bottom and then meron din akong force on top. Ayan. So, meron din tayong force dito, force sa side, sa magkabilang side. Ayan. Pero yung mga forces na to ay maka-cancel out. Ayan. So, meron akong idadagdag sa drawing natin. Okay? So, kumwari, kung alam ko ang distance na to, ayan. So, let's call this height 1. And then, ito yung side nung ating ang tawag dito, cube. So, isang side ng cube natin given. At yung kung nasaan yung pinakababa ay given din. Ayan, mula dun sa surface. Kumala surface ito. Surface. Ayan. So, let's call this height 2. Ayan, height 2. So, given tayo ng height dun sa top nung object natin, papunta dun sa surface, and then yung height, depth from the surface, papunta dun sa pinakababa ng cube natin. Ayan. Okay? Ang sabi ni Archimedes, ang buoyant force daw ay equal siya sa weight of the displaced liquid. Yan. Weight of the displaced fluid. Okay. Kung titignan natin yan, okay, ano ang weight ng na-displace na liquid? Okay, so yung weight ng na-displace na liquid ay equal siya doon sa equal siya sa mass ng liquid times gravity. Okay? Pero based on density, which is mass over volume, ang mass ay equal siya sa density times volume. So yung weight ng displaced liquid ay equal siya sa density volume times volume of the liquid displaced, density of the liquid times gravity. Okay? Times gravity. Ngayon, ang problema natin ay yung volume. Okay? So, sa volume tayo. Ayan, volume. So, meron tayong iba-ibang klase ng volume. Okay? Volume, paano ba natin i-describe yung volume of the displaced liquid? So, meron tayong dalawa, yung fully submerged at saka yung partially submerged. Pag fully submerged, syempre, yung mga mabibigat na object, pag fully submerged is buong buo, yan. So, buong buo ay nasa ilalim siya ng tubig. So, pwedeng buong buo nasa ilalim siya ng tubig. So, ibig sabihin, pag fully submerged, ang volume ng displaced liquid ay equal siya sa volume of the object. Pag fully submerged, yung volume ng displaced liquid ay equal siya sa volume ng object. So, remember that one. Pag partially submerged, so, halimbawa ganito, yan. So, ito lang yung naka-submerged part. So, yung volume ng liquid na na-displace ay equal lang siya dun sa volume ng object's submerged part. Okay, kung ano lang yung naka-submerge, yun lang yung volume ng liquid displaced. Pag fully submerged, kung anong volume ng object, yun yung volume ng liquid na displaced. Pag partially submerged, kung ano ang volume ng object na naka-submerged part, yun lang yung volume of the displaced liquid. Nakuha niyo ba? Okay. So therefore, we can conclude that buoyant force is equal to the density of the liquid, volume of the displaced liquid, times gravity. Ayan. Times gravity. So that is the definition based on Archimedes. Okay, may question? Wala. Now, let's go to the definition ng una natin. Okay, so, i-derive ko. Okay, so by the other definition of buoyant force, ang sinasabi ng first definition natin na yung buoyant force daw ay equal siya sa sum of the forces, which is equal to force at the bottom minus the force on top. Yan. Force at the bottom minus force on top. So that means, ano ba yung, pero ang pressure kasi natin is equal siya sa force over area. Okay, so that means, ang force natin ay equal siya sa pressure times area. So therefore, ang buoyant force natin is pressure on top, at the bottom, times the area at the bottom, minus the pressure at the on top, times the area on top. Ngayon, so given tayo nito, sa bottom pala, yan. Paano natin kukunin yung pressure at the bottom? Okay? So, meron tayong force dito. So, ano yung pressure at the bottom? At ano yung pressure on top? Okay, so by hydrostatic pressure, di ba pressure is equal to pressure, rho GH. Okay? So that means, ang buoyant force natin ay equal siya sa rho GH2, which is at the bottom, times area, minus rho GH on top, times area on top. Okay, H1 ito. Okay? Question. Okay, next. So we can factor out. So buoyant force now is equal to, we can factor out rho G A times H2 minus H1. Tama ba? Okay. So, pero dito sa figure natin, tingnan ninyo, ang figure natin. So, how will we relate H2 and H1? Okay, so based sa figure, di ba? H2 is equal to H1 plus S. So, therefore, S is equal to H2 minus H1. So, if you substitute that, therefore, the buoyant force is equal to rho GA times S. But what is A times S? Kung may area tayo dito times S, based on the figure, A times S is equal to the volume. So, therefore, ang buoyant force is still rho VG. Ayan. Which is the same as that of Archimedes' principle. Okay? So, any question? So, ang buoyant force natin ay equal siya sa rho VG. Yun lang talaga yung formula natin for buoyant force. Okay? So, meron akong question. Masasagot niyo lang to ng yes or no. Ang question ko ay, is it possible that weight is equal to the buoyant force? Wala pa man akong tanong, may sagot. Is it possible that the weight is equal to the buoyant force? Okay, so yung una kong tanong ay, is it possible that weight is equal to the buoyant force? Weight of the object is equal to the buoyant force. Okay. Sige. Okay. So, hati ang ating so far, ayun, ang nag-yes at mag-may no. Di ba mamaya sasagutin kasi yan. Ilista ko muna. So, merong 30 na nag-yes, 3 nag-no. Okay, so next question. Is it possible that the weight of the object is greater than the buoyant force? Sandali. Next poll to. Yes or no? Is it possible that the weight of the object be equal to the buoyant force? At ang last question natin, baliktad. Pero yung question, yung poll na yan is para pa lang dito sa ating. Is it possible that the weight of the object is equal to the buoyant force? Yan. So that mabilisan lang yung poll natin. So 8-4. Nangyari dun sa iba. Oh, hindi. 10 na. 10, 10, 11, 11-4. Okay, next poll. 11-4 yung sagot kanina. Is it possible that the weight is less than the buoyant force? 11 to. Yeah. Nag-iisip sila. Ayan. So, ang sumagot ay one, two, three, four, five. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 1. Yan. Para hindi ako nagkakamali. Ayan. So, meron tayong 11 versus 5. Okay, 11 versus 5. So, 11 versus 5. Okay, so, nana natin. First is it possible that the weight is equal to the buoyant force? Yes. So, the answer, of course, is yes. Okay, so what will happen if the weight is equal to the buoyant force? Okay, so the object will float. Okay, so that's why we have floating objects. It means that the weight is equal to the buoyant force. Okay, so ano mangyayari dun sa object? Ayan, ang sabi ni Archimedes. Ayan, Archimedes principle on floating objects. That the density of if the density of the object is less than the density of the fluid, the object will float. Ay, class, you remember that. Kaya ito ay naka-base lang tayo sa density. Pag ang density ng object ay less than sa density ng liquid, ayun, magfo-float yung object na may mas mababang density. Tatandaan niyo yun. Okay? Next, the object is in static equilibrium. It will not be moving. Ayan. And then the object is only partially submerged. Yeah, the object is only partially submerged. So that means it's partially submerged. It's not fully submerged. That's why it's floating. The object will float based on this, according to Archimedes. And then the upward buoyant force is balanced by the downward force of gravity. So that means buoyant force is equal to the weight of the object. And the volume of the liquid displaced corresponds to the volume of the object beneath the fluid level. So kung ano lang yung naka-submerged part, so yun lang yung weight ng liquid ng equal siya sa buoyant force, yung na-displace na liquid. Okay. Ayan. So let's have the next question. Is it possible that the weight of the object is greater than the buoyant force? Yes. The answer is yes. That means the object will kabaliktaran ng float. The object will sink. So, halimbawa, di ba yung bato? Yan. So, yung cylinder na yan, di ba yung may graduated cylinder, pag nilagyan mo ng bato, pupunta siya sa baba. Ayan. So, magdi-displace yung liquid natin. Yung weight na to, ng liquid, okay, yung weight ng object ay greater siya sa weight nung na-displace na liquid, which is the same as the buoyant force. So, ibig sabihin, yung buoyant force ay hindi kinaya yung weight ng object, kaya nag-sink yung object. nag-sink yung object. Okay, next. Is it possible that the weight of the object is less than the buoyant force? Um, I, I, for this one, I don't know if I could answer it directly na no, yes. Pero parang hindi. Parang hindi yata. Kasi, halimbawa, meron ka bolang nilagay sa tubig. Di ba initially, nasa taas siya? Pag nasa taas siya, konti lang yung nakasubmerge. So, ibig sabihin, yung weight of the object equal siya dun sa buoyant force. Ngayon, para magkatotoo ito, kailangan mag-exert ka pa ng additional force na itulak mo siya pababa. Ayan. Na itulak mo siya pababa para lumubog siya. Kung isasummation natin yan, yung buoyant force equal siya sa weight ng object plus yung applied force. So that means, mas malaki yung weight ng object, buoyant force, kesa dun sa weight ng object. Pero, dahil nag-apply ka ng force. Pero pag tinanggal mo itong force na to, tendency is tataas siya ulit at babalik siya sa ganitong position. Ayan. Kaya, parang indirectly, kung sila lang dalawa, weight and buoyant force, parang hindi po pwede. Kasi kailangan mong may gawin para magkatotoo yung relation na yan. Nag-guess nyo ba, class? Okay? Any question? Walang question. Okay. So, tatandaan niyo yung sinabi ni Archimedes, babalik ko lang siya dito, na yung density of the object is less than the density of the fluid in order for the object to flow. Okay. Now, is it possible naman na pag nilagay ko yung object, hindi siya mag-float at hindi rin siya magsisink? So that means, nandito lang siya. So, ito yung pinaka-bottom. Nandito lang yung object natin. Nakstay lang, naksteady. Is that possible? Magpa-poll ako kasi di sumasagot sa chat. Is it possible na pag nilagay mo yung object doon sa liquid or doon sa tubig, ganyan lang siya. Float lang siyang ganyan. Steady lang siya doon sa tubig. Fully submerged siya, ya? Fully submerged. Pero steady lang siya doon sa tubig. Okay, nagsabi kayo ng yes. Paano yun naging posible? Paano yun mangyayari? Ay, nagnono na yung iba. Nagnono na yung iba. Paano mangyayari naman yun? Yung mga nag-no, bakit no? Yung mga nag-yes, paano mangyayari yon? Okay. Isang way para mangyari yan ay dapat, okay class, anong sabi ni Archimedes? Okay, meron siya binanggit about density. So, para mangyari yan, dapat yung density ng object na yon at saka yung density ng liquid, pareho sila. Tama ba? May sense ba yung sinabi ko? Kasi it's neither magpo-float siya nor magsisink siya. Kasi pareho sila ng density. Tama ba? Okay, sabihin na natin, okay, tama ako. Tama ako. So, meron bang ganon? Meron bang dalawang magkaibang matter pero pareho sila ng density? Very good question, Prince. Very good question. Mamaya, sasagutin ko yan. Sasagutin ko yan. Gandang question. Okay, doon muna sa question na yun. Is it possible? Okay, possible na mag-float yung object na yan kung pareho sila ng density ng liquid. Kasi kung hindi sila pareho ng density, it's either lulutang siya or magsisink siya. Tama ba? So, based on sa Archimedes principle natin. Ngayon, is it possible naman ba, or so, yung mga nag-yes, okay, so yun yung pinakamagandang parang explanation. So, dapat pareho sila ng density para mangyari yon. So, yung mga nag-no naman, okay, it is not possible kasi wala namang material na pareho sila ng density. So, yun naman yung argument. Okay. Tama ba? Ayan. Kaya, class. Pero, may exemption. Merong isang object or isang bagay or isang living thing na kayang gawin yan. Siya ang exempted. Ano yon? Na kaya niyang magganyan. Yeah, very good, Karen. Sila lang. Sila lang ang may kakayahan gumanyan. Okay, dahil ang isda, siya lang ang may kakayahang mag-swimming ng pataas, pababa, paurong, at saka pasulong. Yung mammals, hindi naman nila kayang gawin yan eh. Balyena, hindi naman niya kayang gawin yan eh. Pero yung isda, kaya nilang gawin yan. Okay? Kasi, merong organ yung isda na kaya niyang palitan yung kanyang density. Kaya nagagawa niya yan. Okay? So, sa ganyang or sa ganyang ability ng mga isda, doon nila dinevelop yung submarine. Kaya yung submarine, kaya niyang gawin yan. Kaya lang yung submarine kasi din, kaya niyang magpalit ng density din. Diba, parang merong compartment sa submarine na naglalabas at saka nagpapasok ng tubig doon sa submarine mismo. So, parang may compartment. So, kung gusto na niyang pumunta sa taas, okay, ilalabas niya yung tubig or mag-inflate siya ng parang salbabida, ganon, para tumaas at bumaba yung kanyang density. Para tumas na siya. Pero kung lulubog na siya, magpapapasok siya ng tubig doon sa isang compartment na yon or inflate niya or tatanggalan niya ng hangin yung mga floaters niya para mag-sink siya. Okay? Okay, next naman. O, yun punta tayo dun sa tanong ni Prince. Bakit? Merong mga joke yung mga bata. Sinasabi nila, ano bang mas mabigat? Ang barko o ang karayong? So, siyempre, mga engineering student kayo, don't tell me naman na mas mabigat yung karayom. Kasi daw, ang karayom, magsisink siya sa tubig, yung barko magpo-float. Siyempre, bata ba? Ano lang ng mga bata. Pero siyempre, kung engineering kayo, siyempre mas mabigat naman yung barko compared doon sa karayom. Okay? Ano ba yung difference? So, ito na yung sagot. It has something to do with the base area. Probably, pero it still has something to do with Archimedes principle. Yung sinasabi niyang density. Okay? Ang density kasi ng karayom, which is purely solid, density niya is solid. So that means lulubog talaga siya. Ang barko kasi, hindi naman siya purely solid. Yung surface tension, it could help. Yung base area also could help, probably, surface tension. But basically, it has something to do with density. Di ba yung barko ay hindi naman siya purely solid. At the same time, meron siyang mga holes at meron pa rin siyang hangin. Kahit malaki siya, yung density niya ay mas mababa compared pa rin dun sa density ng tubig. Kaya, pag nagde-design daw sila ng barko, meron lang limitation doon sa number of people na pwedeng sumakay. Kasi baka magbago kasi yung density niya at tumaas siya compared doon sa density ng tubig. Parang i-compute pa rin lahat ng density ng butas, imagine mo, mas mababa ang density ng air kaysa sa density ng tubig. Sobra. So, parang ang gagawin ay i-compute yung density ng air pa rin, parang ganon, or density ng barko in general, since hindi naman siya solid, kaya mas mababa yung density niya compared sa density ng tubig. Nasagot ko ba ang tanong mo, Prince? Lahat, total density. Not just the barko. Kasi inisip natin barko mabigat. But it has something to do with density pa rin. And of course, yung surface tension ng tubig at saka ng barko, base area, probably it could help them. Pero generally, has something to do with density pa rin. Kaya nililimit pa rin naman yung sinasakay na tao dun sa barko kasi baka tumaas masyado yung weight niya over its volume. Okay? Di ba density is mass over volume? Yung weight. Yung mass niya, tumaas pa rin compared dun sa volume niya. Baka tumaas yung density niya. Kaya yun yung tinatry nilang hindi mangyari. Okay? So, yan yung ating Archimedes principle. Ayan. So, ano bang ginawa ni Archimedes before? Ayan, in terms yung sa pag-check kung yung gold is totoo ba or hindi. Kasi alam natin yung density ng gold. So, we can solve the density using Archimedes principle. Ayan. Okay? Wala na bang ibang tanong? O bakit yung tao? Yung tao ba ay based on density, lulubog or mag-float? Yung tao, in general. Depending on the depth of water fossil. Okay, Mark. Mark, please explain. Please elaborate your answer. Kindly elaborate your answer. Okay? Depende. The deeper you go, water, the more pressure certified the water. Okay. I am not actually... parang hirap ng tanong, no, Mark? No, Mark? Mahirap ba yung tanong ko? Ang una ko kasing tanong ay, ano ba yung ulit? Ang tao ba, lulubog, lulutang sa tubig? Medyo mahirap ba yung tanong na? Um, ayan. Si Franklin meron na siyang sagot. Pag di marunong lumangoy, magaling yan. Lulubog. Tama naman, no? Di ba? Tama yung sagot. Pag di marunong lumangoy, lulubog. Oo yan. Marunong ba kayong lumangoy? Okay. You'll naturally float sa salt water. Pag yung density mo ay mababa sa density ng salt water, yes, you will float. Ang problema kasi ay, I'm not sure, I could be wrong, but this is how I understood it. Meron na, ang tao lang ang kailangan matutong lumangoy. Tama ba yung sinabi ko? According to, sa mga nabasa ko, ang hayop, kahit ilagay mo pa siya sa tubig, kahit first time niya, makakalangoy siya. Ang tao, kailangan matutunan na siyang lumangoy. Ewan ko ano ba nakalimutan ng tao, kailangan matutunan niya muna ulit yon. Kaya, isa pa, kasi di ba we breathe? Lahat ng animals we breathe. So that means, if we breathe air, so pwedeng magbago yung density natin. Tama ba? Kaya, pag kasi nagpapanik ka, yung breathing mo, hindi mo makontrol, kaya pag lumalabas yung hangin, tumataas yung density mo. Pag nagstay yung hangin ng medyo matagal sa katawan mo, sa lungs mo, bumababa yung density mo. So, one way yon. Kaya na huwag kang magpanic. Pangalawa, yung kasing, hindi ko alam naman density ng tao pala. Kaya nagbabago yung density ng tao, the way we breathe. At isa pa ay may may friction kasi between yung tao at saka yung tubig. Kaya kailangan mong marunong i-manage yun. Pero naturally, parang tulubog yata or I don't know. Pero syempre, pag namatay ka or nalunod ka, yung tubig ay papasok sa lungs mo. So, yung density mo ay tataas na. Bakit tatanungin nyo, Sir, ba't lumulutang yung patay? Baka yun naman yung susunod yung tanong. Ba't pag patay lumulutang? Di ba napasokan na ng tubig? Yeah. Siyempre, oo. Talagang magstay ka dun sa baba talaga. Diretso sa seafloor. Okay. Okay. Baka tanong nyo din, Sir, ba't pag namatay naglumulutang? Pag first time. Pagkamatay mo, bawa na nalunod yung tao, ba't kayo nung usapan natin? Parang hindi maganda. Sige. Parang hindi maganda yung usapan natin. Anyway, science naman ang pinag-uusapan natin, technical, di ba? Okay, pag nalunod ka, unang-unang mangyayari talaga, syempre nalunod ka, lulubog ka. Yan. So, hahanapin ka ng mga tao. Pag after few days, hindi ka mahanap, hihintayin ka na lang nila na lumutang. So, initially, talagang lulubog yung tao. Pag hindi nila nahanap after few days, hihintayin nilang silang lumutang. Kasi daw, pag namatay yung cells na lawag tao, parang nagsisecrete sila ng chemical. At binabago niya yung density ng carcass. Hindi man, hindi man corpse, no? Yung katawan. Kaya lulutang yung katawan. So, halimbawa, di ba may mga lumubog na barko, sa search and rescue, hahanapin yung mga katawan. After hindi na mahanap yung iba, so hihintay na lang silang lulutang. Unless hindi pa sila kinain ng kung ano-ano. Or napadpad kung saan-saan. Kasi daw yon dahil pag nag-breakdown yung cells, parang nagsisecrete sila ng chemicals na something para bumaba yung density ng katawan. Okay? Ayan. Parang hindi maganda yung topic natin today. Yung example natin. Okay. So let's go to, wala kayong questions, so let's have an example. Okay. Ayan. So a super tanker with oil, filled with oil has a total mass of 6.1 times 10 to the 8 kilograms. If the dimensions of the ship are those of a rectangular box, 300 meters long, 80 meters wide, and 40 meters high, determine how far the bottom of the ship is below sea level. If the density of sea is 1020 kilograms per cubic meter. So let's draw the figure for this example. Drawing ko muna yung figure. Ang supertanker daw natin ay para siyang rectangular na ano. Yan. Okay, so syempre, partially submerged lang siya. So yung length daw nito ay 300 meters. Tapos yung width niya ay 80 meters. At yung length, 40 lang width. 80 yung length. Saan yung length? 80 yung length, 40 yung depth. 40 yung kanyang depth. Ayan. Okay? So, yan yung super tanker natin. At ang mass niya ay 6.1 times 10 to the 8 kilograms. Ang tanong ay, how far the bottom of the ship is below sea level? So, ang tinatanong ay, kung ito ang sea level, ito yung bottom, gaano daw to kalayo? So, sabihin na natin D. Ano ang D? Okay, D. Kung mag-FBD tayo, FBD, so, ano yung forces acting on the object? So, meron tayong weight at saka yung buoyant force. Or diretso na natin na yung buoyant force, okay? Yung buoyant force, equal siya dun sa rho Vg. Rho Vg. Density of the liquid, volume of the liquid, and then gravity. Okay? Okay. So, based dun sa FBD natin din, FBD, so, kung magsasamation of forces tayo along y is 0, ang buoyant force natin minus weight is 0. So, object. So, yung buoyant force natin equal siya sa weight ng object. Ayan. So, weight ng object. So, therefore, ang weight ng object equal siya sa rho L VLG. Density of the liquid, volume of the liquid times gravity. Ano yung weight of the object? So that's mass of the object times gravity is density of the object, volume of the object, times gravity. And then cancel that. Ayan. Density of the liquid is given. So that is in terms of the C. Ngayon, ang question ay, ano ang volume of the displaced liquid? Ano ang volume of the displaced liquid? Question class. Is our object fully or partially submerged? Yun yung laging tatanungin nyo, fully, partially. Partially. So that means, correct, very good. Partially. So that's equal to the volume of the object's submerged part. Submerged part. So therefore, what is the volume of the object's submerged part? Ito lang yung kukunin yung volume. Yan. Okay, so that is 300 times 80 times yung height na T. Tama ba ako? Volume of the submerged part. So length times width times height. Yan. Length times width times height. Yan. And then substitute na natin siya sa formula natin dito. So 6.1 times 10 to the 8 is equal to density of the liquid. It's 1020 times 300 times 80 times D. So what is D? 6.1. .92 meters. Ayan. Okay. Okay. Any question? Wala. Okay, so let's have another example. Yeah. An ore sample weighs 17.5 newtons in air. When the sample is suspended by a light cord and totally immersed in water, the tension in the cord is 11.2 newtons. Find the total volume and density of the sample. Okay? So, meron tayong object. Ayan. So, air muna tayo sa air. Okay? So, yung weight ng object ay 17.5 newtons. So, the weight of the object is 17.5 newtons. Okay, para sa water na siya, ayan, water, nilagay na siya sa water. So, yung tension daw ay 11.2 newtons. Ayan, 11.2 newtons. Okay, so ano yung density at volume ng sample? Ayan. Okay. Okay, so dito tayo mag-start. So, kung yun yung tension, so that means, kung kukunin natin lahat ng forces acting on this object, so we have the weight and the buoyant force. The weight and the buoyant force. So if you will get the summation of forces is equal to 0 along y, so that means tension plus buoyant force is equal to the weight. So buoyant force then is equal to weight minus tension. Okay? So therefore, buoyant force is equal to 17.5 minus 11.2. So the buoyant force is equal to 6.3 newtons. Okay, ayan. Now, let's go to Archimedes principle. Ayan. Ang buoyant force, i-equal siya sa rho of the liquid, Vg. Okay? Ngayon, ano ang volume of the displaced liquid? Question. Is it partially or fully submerged? Fully submerged. So that means that's equal to the volume of the object. Tama ba? Kasi fully submerged siya. So it's the volume of the object. So yun yung hinahanap talaga natin. So substitute na natin yan. So that is 6.3 is equal to ano yung ang sample natin ay water. So that's 1,000 times the volume of the object times 9.8. So what is the volume of the object? Okay, it's 6.6 hmm, 642.86 times 10 raised to negative 6 meter cube. Ayan. Meter cube. Tama ba ako? 6.3 divided by 1,000 divided by 9.8. Then you press ENG. So, pindutin nyo yung ENG dito para mag-move siya ng decimal. Ayan. 642.86 times 10 to the negative 6 meter cube. Volume. Ayan. Okay? So, that is for the volume. Next, how about density? Okay, density is equal to mass over volume. Okay? Kaya lang wala lang given mass. So, anong gagawin natin? Okay, kailangan natin ng mass. Given kasi tayo ng weight, di ba? But mass is equal to weight over gravity. So, density is weight over G all over V. That's equal to 17.5 over 9.8 divided by 642.86 times 10 to the negative 6. So what's the density of the object? It's 2,777.78 kilograms per meter cube. Ayan. Yes, diniretso ko na lang na dinivide ng gravity to get mass, yung weight natin. Okay, at least, ayan. Okay? Any other question? Let's have this one. A slab of ice floats on a freshwater lake. Okay, class. By the way, so this is also the reason why why ice floats on water, because water is very special. Nag-expand yung water pag tumigas. Kaya lumilit yung density ng tubig pag nag-solidify siya. So that's why ice floats on water. So mas mababa yung density ng yellow compared sa water, even though pareho silang water molecules. H2O. Yeah. Okay. So it's a freshwater lake. Take note of that. So what minimum volume must the slab have for a 45-kilogram woman to be able to stand on it without getting her feet wet? Okay. So, kung normal lake lang yan, so ito yung slab of ice natin. So ganyan yung magiging mangyayari. Ngayon, pag umapak daw yung woman, ayan, ano daw dapat yung volume ng ice natin? Wala siyang kamay. Ayan. Okay? Ano dapat ang magiging volume ng ice para yung sakto lang na hindi siya mababasa doon sa tubig? Okay. Ngayon, ayan, mag-FPD muna tayo. So, FPD. So, what are the forces acting on the ice? So, we have the weight of the woman, then the weight of the ice, and, of course, our buoyant force. Ayan. Okay, so let's have the summation of forces along y is 0. So we'll have buoyant force minus weight of the woman plus minus the weight of the ice is equal to 0. Or the buoyant force is equal to the weight of the woman plus the weight of ice. Okay. Ano yung buoyant force natin? So buoyant force is the density of the liquid, volume of the liquid times gravity is equal to what's the weight of the woman? So that's the mass of the woman times gravity. Next, what is the weight of ice? So that's the mass of ice times gravity. Tama ba? And then we can cancel yung gravity. Okay, are we given the mass of ice? Wala. Okay, since hindi tayo given ng mass ng ice, so yung mass of ice natin ay kukunin natin siya sa density of ice. So the density of ice is equal to mass of ice times volume over the volume of ice. So the mass of ice is equal to the density of ice times the volume of ice. So the density of the liquid, volume of the liquid is equal to the mass of the woman plus the density of ice times the volume of ice. Ang question, class. What is the density of the displaced liquid? Okay. Ang question ay, is the ice fully or partially submerged? Okay, it's fully. Kasi saktong-sakto lang na hindi mababasa yung babae. So it's fully submerged. So that means it's equal to the volume of ice dahil fully submerged. Tama ba? Okay, so substitute na natin. So density is 1,000 times VI is equal to 45 plus what's the density of ice? Hindi ko siya memorize. We need the table. So ice is 0.917. So 917. So based on the table, plus di ko napapakita yung table, no? Based on the table, okay, yung density ng ice ay 917 kilograms per cubic meter. Ayan. So that's equal to 917 VI. Okay, so transpose natin magiging 1,000 minus 917, 83. So 83 VI is equal to 45. So what's the volume? Therefore, the volume of ice is 0.54 meter cube. Tama ba ako? Plus 0.54 meter cube. Okay, wala kang question. So let's have another example. Ayan. Okay. A cube of wood having an edge dimension of 30 centimeters is centimeters. If the top surface of the wood is 8 centimeters from the surface, water surface, what is the density of the wood? Second question I, what mass should be placed on top of the wood so that the top will just be of the same level of that of the water surface? Ayan. So let's roll for the wood. The wood is cubical in shape. Ayan. At ang edge niya ay 30 cm. Okay? So based on the given, so the top surface of the wood is 8 cm from the surface of the water. So if this is the surface of the water, yung top daw ay 8 cm. Yan. Tanong letter A. So what is the density of the wood? Yan. So density of the wood. Okay, ang density ng wood ay mass over volume. Tama ba? Density is equal to mass over volume. So we don't have the mass, but we can compute for the volume. So kailangan natin ng mass. Ayan. So pupunta tayo sa summation of forces is equal to 0. So what are the forces? So we have the weight of the wood and of course the buoyant force. So the weight of the wood, buoyant force, minus the weight of the wood is equal to 0. So the buoyant force is equal to the weight of the wood. Ano yung buoyant force natin? So that's rho L VL times G. And the weight of the wood is mass of the wood times gravity. So we can cancel yung gravity. Ayan. Okay, ang question ay sa volume. What is the volume of the displaced liquid? Is it fully or partially submerged? Okay, it's partially submerged. So the volumes object submerged part. Submerged part lang. So what is the volume of the object submerged part? Okay, so ito lang yung volume ng naka-submerge. Okay, so since cube yan, ito ay 30. Ito din ay 30. So that's equal to 0.34 length, 0.34 width. Ano yung height niya? So anong height na to? Okay, so this is, ano? So this is 30 minus 8 or 22 cm. So 0.22 cm. Tama ba? Ayan. So let's substitute them dito. So density of water is 1,000 times 0.3 times 0.3 times 0.22 is equal to the mass of the wood. Okay, so what's the mass of the wood? Okay, 19.8. 19.8. Tama ka ba? Kilogram? Okay, so 19.8. So therefore, density is 19.8 kilograms times 0.3 times 0.3. 0.3 cube pala. Sinula ko pa yun. That's equal to 733.8 33 kilograms per meter cube. O, talagang magpo-float siya kasi ito yung kanyang density. Mas mababa sa 1,000. Okay? Yung letter B, okay, class. Class, bibilisan ko na lang to kasi oras na. Okay, paano yung sa letter B? So, maglalagay tayo daw ng mass dun sa taas. So, magpo-float lang siya. Yung surface niya ay yan. So, yung mass na yan. Okay? Magpo-float lang siya doon sa surface. Yan. Yan. So, ibig sabihin nito, kung magsasummation of forces pa tayo ulit, forces along y is 0. So, that means yung weight ng mass ay yung buoyant force minus weight ng mass, buoyant force, weight ng wood, minus weight ng wood is equal to 0. Ayan. Okay? So, ang buoyant force natin ay equal siya sa weight ng mass plus yung weight ng wood. So, buoyant force is density of liquid, volume of liquid times gravity, and then mass times gravity plus yung weight ng wood. Makuha ba natin siya? Okay, so yung weight ng wood. So, mass ng wood times gravity. So, we can cancel this. Ayan. So, question ay, ano yung volume ng displaced liquid? Is it fully or partially submerged? Yung wood. Is the wood fully or partially submerged? Full na, yeah. Correct. Fully submerged na. So, that's equal to the volume of the wood. Ayan. So, density is 1,000 times 0.3 cube is equal to yung mass plus yung mass ng wood na na-compute natin kanina is 19.8. So, yung mass natin na equal siya sa 7.2 kilograms. Ayan. So, kailangan natin maglagay ng 7.2 kilograms dun sa taas ng wood para saktong-sakto lang yung top ng wood doon sa surface ng water. Okay?